I just wanted to show a couple of modifications I made to Mr. Carlson's low voltage capacitor leakage tester circuit. This is just a redraw of the basic circuit. The two things that I added were, first of all, over here I've got a push button switch, normally open, that allows me to shunt this string of 22 megohm resistors with a 220k resistor. This can be most any value, 100k, 50k. I've used 1.5 meg, whatever. It's just a quicker way to charge the capacitor under test. And over here I've added a meter in parallel with the LED, and in this case it's a 1 milliamp full scale meter, and I've adjusted these resistor values so that when I short the input here, device under test, the capacitor under test, when I short those two together, the green LED lights brightly, and I adjust this potentiometer so that I get a full-scale reading on the meter. It's not critical because you're actually interested in what's happening at the low end of the meter, not so much the high end of the meter. But I'll show you how it works when I go to the circuit, the working circuit. So this milliamp meter, as Mr. Carlson pointed out in his video with the bar graph display, it will still be displaying a value when this green LED is out. So it increases the sensitivity somewhat. Other than that, it's pretty much the same. I've got a different filter section here. Mr. Carlson had a pi section filter. I just did this. It works fine. All right, so let's move on to the actual circuit. So here I have the prototype circuit. My push button for bypassing the 66 megohm string of resistors. I think I've got, what, a 330k resistor shunting it. And over here I have my meter, 0 to 100. 100 is 1 milliamp full scale. This is a little trimmer pot for adjusting the meter for full scale deflection. This is the LED and Mr. Carlson's circuit. So if I short these two leads together here, you will see that I get the green LED, and I'm going to adjust my power supply so I get a full scale reading on the meter. It still drops to 0. Yes, it does. All right, so ready to test. This is a good capacitor, 0.22 microfarad. So stick him in there, and you will see that if we just wait here, see the meter going down, the LED getting lit dimmer, and there we go. Good capacitor. But you know, that took a fair amount of time. So if I take this capacitor and we flip it around, once again, get the green LED, but if I push this button, it goes to 0. And if I release it, it stays there. Okay, so that's a good capacitor. Now let's go take a bad capacitor. It's a little 0.22 microfarad, 200 volt super pup. Let's put him in the circuit. Clip him in there. There we go. Let's just wait. See what happens here. Well, that's bright in the camera, isn't it? as you can see, it's taking a while. Now, let's push the button, put the 330K in there, it goes to 0. If I release the button, what happens now? There you go. I quickly charged it, but as soon as I released it, it's discharging because of its internal resistance. Let's take another capacitor. This is a Sprague 0.5 microfarad. It says 5 microfarad, but I think that decimal point was rubbed off. 600 volt DC capacitor. I put that in the circuit. Once again, we can go to 100%. And we can sit here and wait and see what it does. But that 0.5 microfarad, it's going to take a while. So if I quickly push this button, it'll go to 0. And it stays there. Oh, no, see, it's climbing up. So that is a leaky capacitor. And the LED is gradually getting brighter. All right, now if I take this and let's say I flip it around, once again I can push the button, take it to 0, and now it's coming up faster. Now I find that there's more to this than just the resistor or the capacitor becoming resistive. Because if I push this button and charge the capacitor, and I charge it for, let's say 10 seconds. 5, 6, 7, 8, 9, 10. Then I release it. And wait. It'll sit there at 0. No leakage current. And I've let it sit there for over an hour. No leakage current. So there's something else going on other than the capacitor becoming resistive. Because I can leave it here for over an hour and it won't indicate any current at all. Just an interesting little tidbit that I found while playing with these. Well, that's about it.